Hey math kids, today we're going to combine combinations and probability. So let's just get started right here. So there are 6 ghouls and 4 ghosts in No Prob Rob's class. Their teacher wants to form a committee of 3 paranormal entities. If the committee members are randomly selected, what is the probability that the committee will consist of all ghouls? So essentially what we're going to do, we're going to find out how many different committees can be formed of just all ghouls, and then we're going to divide that by all possibilities. So that's essentially going back to the idea of what we want divided by the total. Okay, so first we need to count how many different ways we can get all ghouls. And so there are 6 ghouls, and we were choosing 3. So we're going to do a 6C3 for the top. And then we're going to do all possibilities. So there's 6 and 4, so there's a total of 10, and we're still only choosing 3. Okay? So let's find the 6C3, which is going to be 6 factorial over 3 factorial times 6 minus 3 factorial. Look at one of the previous videos about permutations and combinations if you need to see that formula written out. Okay, and that's going to be 6 factorial over 3 factorial, 3 factorial, because 6 minus 3 is 3. 6, 5, 4, 3, 2, 1, 3, 2, 1, 3, 2, 1. So we cross these out. 6 times 5 is 30. 30 times 4 is 120. 3 times 2 times 1 is going to give us 6. And if we do 120 divided by 6, we end up with 20. So the top of our fraction is 20. Now we're going to go through 10 C3. So that's 10 factorial, 3 factorial, 10 minus 3 factorial, which gives us 10 factorial over 3 factorial, and then 10 minus 3 is 7. So we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 3, 2, 1, and 7, 6, 5, 4, 3, 2, 1. Cross out everything from the 7 on. And just to make life a little bit easier, that's going to be 720. But I have a feeling that some of these later ones are going to be harder. So let's just start using a calculator. So we have 10 times 9 times 8. That gives us 720. 3 times 2 times 1 is 6. And if we divide that by 6, we end up with 120. So the bottom of our fraction is 120. So to find the final probability of getting what we want, we just have to do 20 divided by 120. So the probability is 0.167, or if we round that, or if we, turn that to a percentage, it's going to be 16.7. And if we round that to the nearest percentage, we're going to get about 17%. Okay? Now let me just erase everything. So the next one is going to be pretty similar to what we just did. Okay. So number 2, there are 7 managers and 10 low-level employees at a department store. Karen enters the department store with a coupon that has been expired for 6 years and an item that is 19 months past its return by date. The employees decide to randomly select a 3-person committee to deal with the battle that will surely ensue. What is the probability that the committee will consist of all managers? Because this is the only committee that has a chance of victory. Okay, so we want to know how many different all manager committees we can make and divide that by all possible outcomes. Okay, so all the managers, we have 7 managers and we need to choose 3. So 7C3, and then the total possibility is 17C3 because we have 10 low-level employees and 7 managers. All right, so we get 7 factorial over 3 factorial times 7 minus 3 factorial. So that's 7 factorial over 3 factorial, 4 factorial. 7 minus 3 is 4. So we get 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1, and 4, 3, 2, 1. Cross out as much as we can. Go to our calculator. 7 times 6 times 5. We get 210. 3 times 2 times 1 is 6. Divide that by 6, and we end up with 35. So the top of our fraction is 35. Now if we do this one, we get 17 factorial over 3 factorial and 17 minus 3 factorial. So 17 factorial over 3 factorial. 17 minus 3 is going to be 14 factorial. And so we get 17, 16, 15, all right, we have all those numbers. And then from 14 down, we're going to be writing these as well. So if you don't really want to write them all out, you don't have to. And then 3 factorial is going to be 3, 2, 1. So all of this is going to go away. So we're left with that. So we're going to say 17 times 16 times 15. That gives us 40, 80. And then divided by 6 again, 3 times 2 times 1. So that's 680. So that's going to be the bottom of our fraction right there. And so 35 divided by 680. We get 0.051. And so that's about 5% if we round it. So we only have a 5% chance of winning the Karen battle. Okay, let's do one more, just because these are kind of involved. There's a lot of conceptual stuff going on here. If you're good at all the parts conceptually, though, this really isn't that hard. It's kind of tedious, though. All right. So this time, X Peer X rolls a standard 6-sided dice. He rolls the dice 4 times as part of a board game. What is the probability that exactly 2 of her rolls are 5s? So we have a 6-sided dice, and it's rolled 4 times. So what I like to do, I like to create 4 sets of parentheses. Each one represents 1 roll of the dice. Now we want it to be exactly 2 of them are 5s. So we're going to start with successes first. So we're going to say we have a 1 in 6 chance of getting a 5. We have a 1 in 6 chance of getting a 5. So this is rolling a 5, rolling a 5. And then these ones we want anything but a 5. So not 5, not 5. So for that, to get not a 5, we have a 5 out of 6 chance with both of those. All right, so all we need to do is multiply the tops. So 1 times 1 times 5 times 5 is going to be 25. 6 times 6 times 6 times 6, or 6 to the 4th, is going to be 1296. And if we divide that, we're going to get 25 divided by that. And so we get 0.019. Or if we translate that into a percentage, we're going to get 1.9%, which if we round that is about a 2% chance. Okay, if you have any additional questions, come to Math Lab. Until then, calculate.